Okay, so what we're going to focus on today, we are going to use the hypotenuse leg postulate to prove right triangles are congruent. Now, we can still prove right triangles are congruent by one of the other methods, but this one specifically only works for right triangles. So remember the other day, or I shouldn't say the other day, back in the beginning, when we said angle side-side doesn't work. And I got the skewer sticks out, and I think I was showing Easton why, because you got two different triangles. Now, technically, I guess I lied. Angle side-side does not work in general, but it does work if your triangles are right triangles. And we don't call it ASS then. We call it, since it's a right triangle, we call it hypotenuse leg. Okay, so the hypotenuse leg theorem states, if there exists a correspondence between the vertices of two right triangles, such that the hypotenuse and a leg of one triangle are congruent to the corresponding parts of the other, then the two triangles are congruent. So technically, you still have three pairs of parts that you know. You have a pair of right angles. You have a hypotenuse from each right triangle. And you have a leg. Okay, so again, if there exists a correspondence between the vertices of two right triangles such that the hypotenuse and a leg of one triangle are congruent to the hypotenuse and leg of the other triangle, the corresponding parts, then the triangles are congruent. And again, we call this, for our method, HL. Okay, so if we need it, like I said, the hypotenuse is the one across from the right angle. So in triangle ABC, the hypotenuse would be the segment AB. That's your hypotenuse. It's the side across from the right angle, if you need a refresher. So in my other triangle EFD, the hypotenuse would be segment ED. Again, that's your hypotenuse. It's the one across from your right angle. So again, what you're going to have throughout the proof, if you're proving triangles are congruent, or maybe you're proving a CP-CTC step. We're not adding an extra step. We're just giving you a different option for proving triangles congruent. So notice in this situation, we're given that segment AB is congruent to segment DE. That's the hypotenuse of each one. You're given segment AC is congruent to segment DF. That's your leg. And you have angle C and angle F are right angles. So hence, it's not, if you ever think, is it angle side-side? You don't write that. Angle side-side doesn't work unless it's a right triangle. And again, then we call it HL, hypotenuse leg. So what we're going to look at example-wise, I've got two of them set up for you in the notes. We're not adding additional steps at the end. We're just talking about another option for proving triangles congruent. So rather than side, 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 angle, we now have HL. Only difference about today. Maybe it's stopping with proving triangles congruent. Maybe it's a CP-CTC step. Okay? But again, we're looking at a different option for proving triangles congruent. Okay, so let's take a look at the first one. So on this one, let's go technology. It's thinking. Turned kind of light. Maybe. There we go. Okay. So on this one, we are given that segment GJ is perpendicular to segment HK. We know that segment HG is congruent to segment KJ or KG. We are trying to prove that these two triangles HGJ and KGJ are congruent. So most likely you would think that I'm probably going to use this new theorem, this hypotenuse leg. Okay, so starting from the beginning here, if we start with the given, if segment GJ is perpendicular to segment HK, when you have perpendicular lines, what do you have? Right angles, okay? So after my statement about perpendicular segments here, I can specifically state that angle GJH, so angle GJH is a right angle, and so is angle, oh, that's a typo on my part. That should be GJK, I bet. So again, I've got right angles in the picture. So again, that should be angle GJK, being a right angle. Okay, what's my reason? Yeah, if two segments are perpendicular, then they form right angles. Okay, so let's see here. So if two segments are perpendicular, then they form right angles. So again, kind of writing this out. There we go. And we have the right angles in our picture. Okay, everybody good so far? So we could possibly use this HL because we do have right angles. We also know from the given, segment HG is congruent to segment KG. So HG is a hypotenuse. Segment KG is also hypotenuse. Okay, so if I'm going to do HL, what am I missing here? The leg, right? We got the hypotenuse near the leg. Notice they butt up against each other. So we could state that segment GH, or I typed this wrong. I apologize. So this should be segment GJ, congruent to segment GJ, and that is your reflexive property. Okay, so is that enough to state your triangles are congruent? What's my method going to be? HL, hypotenuse leg. So triangle HGJ is congruent to triangle KGJ by hypotenuse leg. So, did we add any extra steps? No, we actually saved one because normally we were saying that if two angles are right angles, they are congruent. You don't actually have to state the right angles are congruent in this one because you just need to know that they're right angles. Okay, questions about that one? Okay, let's take a look at the other one then. Everybody good? So again, we're not making them any longer. We're just looking at a different method. So in this one, we are given that we have circle O. We know that segment YO is perpendicular to segment YX, and segment ZO is perpendicular to segment ZX. We are trying to prove that segment YX is congruent to segment ZX. So hopefully you can picture in your mind here, we could add a segment down the middle here, right? If we can prove these two triangles are congruent, then we could state that segment YX and ZX are congruent by your CP-CTC step. So again, we're not making them longer. We're just looking at another option for proving triangles congruent. Okay, now, some of you would do this in a different order, but the way I have it set up, let's just go with the order that I have. If you have perpendicular segments, in this case YO and YX, what do you know? That you have right angles. So we can state that angle OYX is a right angle. My reason, if two segments are perpendicular, then they form right angles. So right now, I have a right angle at Y. You could actually just state, if you wanted to, that angle Y is a right angle. I'm okay with that. Okay, now, other than you're having a circle as the given, the third part of the given was that segment ZO and segment ZX were perpendicular. So again, when you have perpendicular segments, you have right angles. So you should have angle Z, or with three letters, angle OZX, being a right angle. And my reason is the same as this one. If two segments are perpendicular, then they form right angles. So I can scroll down a little bit here for the people in the back. Okay, everybody good so far? Okay, so next, I would actually draw in that segment I was talking about. Draw in segment OX. My reason, we should know by now, 2 points determine a segment. So I'm going to scroll back up here, and I'm going to draw in segment OX. So you can see now I've got my 2 triangles. So again, draw segment OX. My reason, 2 points determine a segment. Okay, so if you think about, I have 2 right triangles. I still have to get them congruent. So I still have to have a hypotenuse congruent, a pair of hypotenuse congruent, and a pair of legs congruent. And hopefully you see maybe where this is going to come from the picture. Since we drew in segment OX, if I go back to the picture here, OX is in both triangles. So we can say OX is congruent to OX by reflexive. That's the hypotenuse in each one. That's the one across from the right angle. So again, OX is congruent to OX by the reflexive property. So that's the hypotenuse, the one across from the right angle. Where are we going to get the leg from? Okay, Abby?
YO is congruent to ZO because all radii are congruent.
Good. YO or OY and ZO or OZ are congruent because we know all radii of a circle are congruent. I'll come back in a moment here, but I'm going to scroll up for a moment. Those are going to be these 2. Because again, all radii of a circle are congruent. So hopefully you notice that should be enough to prove your triangles are congruent. So you can state triangle OYX is congruent to triangle OZX by HL, hypotenuse leg. And if your triangles are congruent, the rest of the parts have to be congruent. So we can state that segment YX is congruent to segment ZX by CPCTC. So again, are we adding extra steps? No. Are they getting longer? No. We're just talking about another method. They're not any longer. Okay, you're just using a different method. Now, I have one adjustment I need to make on the assignment. So I know some of you maybe still be writing. Let's take a look at the last page where it has the assignment. I want to make one adjustment to one of the problems. And I didn't make the adjustment before I ran off your copies here. Okay, so if we look at this page here, I've got a little arrow at the bottom for a side note. So you have numbers, page 158, 2, 4, 6, 12, 14, and 15. 14 and 15 are not proofs. On number 6, I want you to change part of the given. So if you're looking at the problem in the book, you'll see what I'm talking about. But in the given, on number 6, you're going to change, it says GJ is an altitude in the problem. Change that to segment GJ is perpendicular to segment HK. And again, if you are looking at the problem, you'll know what I'm talking about. The second part of the given, again, says segment GJ is an altitude. Change it to this. Change that to segment GJ is perpendicular to segment HK. Because we haven't done actually any proofs where we start with the fact that it's an altitude. Everybody understand what I'm saying? So on number 6, in your homework assignment, it's in the book, you're going to change where it says GJ is an altitude, you're going to change it to segment GJ is perpendicular to segment HK. Because of the fact that we haven't actually started off saying any of them were an altitude. Okay? Question?